Today we're talking about sigma notation, and we briefly talked about sigma notation in our geometric notes last week. But sigma is a Greek capital letter. It kind of looks like a sideways M or a funny looking E. It stands for sum, S-U-M. We're adding values together. In terms of our notation here, n equals some number down here. That's going to be the first number that we're dealing with. And the number on top of our sigma symbol is going to be the last value of n. And then our a sub n is going to be our nth term equation in there. And how it works is that we have here, evaluate the sum from n equals 1 to 6 of the function 2n plus 11. What we do is we say, well, the value of the function when n equals 1, we're going to put 1 back into our function, so this is 2 times 1 plus 11. And 2 times 1 plus 11 is 13. Well, n equals 2. It's 2 times 2 plus 11. We start 1, and then we're going to increase all the way up from 1, 2, 3, 4, 5, 6. Well, 2 times 2 plus 11 is 15. N equals 3. It's going to be 2 times 3 plus 11. That means that our third term in our sequence here is going to be 17. When n equals 4, our fourth term in the sequence is going to be 19. Our fifth term in the sequence is 2 times 5 plus 11, which is 21. And finally, our sixth term in here is going to be 2 times 6 plus 11, which is 23. So we can find the values in our sequence. If we add them all together, then what we're talking about is the series. And that's what that symbol means. So if we take our calculators and we add 13 plus 15 plus 17 plus 19 plus 21 plus 23, we get our value of the sum of this particular sequence or series, which is 108. By the way, what kind of sequence or series is it? The two choices being arithmetic or geometric. Tiffany? And it is. Do you know what the common difference is, Tiffany? 2. And it is. 15 minus 13 is 2. 17 minus 15 is 2. 19 minus 17 is 2. So our common difference is 2, which that's just a little bit extra there. But I do want us to be able to try to identify whether something's arithmetic or geometric. So there's our first value here. Let's look at number 2. Not quite as lengthy. We're going to start from 1 to 4. So we're going to figure out our values in our sequence, putting 1 back into the function wherever we see n. So it's going to be 5 times 2 to the 1 minus 1. And you can type this in your calculator. That actually is 5 times 2 to the 0. Anybody know what 2 to the 0 equals? Jordan? It equals 1. 5 times 2 to the 0, so this is 5 times 1, which is 5. you can still type that in. You don't have to know 2 to the 0, but every time I get a chance to talk about that, I want to remind people that any number to the 0 power does equal 1. But more importantly here, we're looking at this particular sequence and we're finding our values of the first 4 terms. So this is going to be 5 times 2 to the 2 minus 1, which equals 5 times 2 to the first. And 5 times 2 to the first is 10. Moving on to our third term, this is going to be 5 times 2 to the 3 minus 1, which is 5 times 2 squared. Very well. 5 times 2 squared, which gives us 20. And this sigma symbol, again, means to add. We're going to be adding all of these values up once we find our fourth value, which is 5 times 2 to the 4 minus 1, which is 5 times 2 cubed, which is 40. And once again, we're going to add these values up to find our answer to the sum of terms 1 through 4 in this particular sequence. And it was 5 plus 10 plus 20 plus 40 gives us 75. What kind of sequence or series is this one? Tiffany? It is geometric, which means that we have a common ratio. And what is our common ratio, Tiffany? Do you know? It's doubled, so 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. There's your double. It is. So there we have. We need to be able to identify whether something's arithmetic or geometric. So as we jump down here to number 3, got some additional information here, and the last thing that we really want to do is start at 10 and go up to 75 and figure out all of those values in between and add them up. That would not be very fun, although I know that I'm going to have some people do it. But what we can do is we can look at a couple of values here. For instance, let's start at x equals 10. And so this is going to be 2 times 10 minus 200. And you can type it in your calculator, but hopefully I have done my math correct on my notes. And that gives us negative 180. And we can look at x equals 11. 10 is our first value that we're going to look at. Our first term, the 10th term in this sequence, is going to be negative 180. Well, we put 11 back into our function. 2 times 11 minus 200 gives us negative 178. We can do 2 times 12 minus 200, and again, I have typed them in ahead of time so that I don't have to type them in on the screen up here to get negative 176. What kind of sequence or series are we working with here? Bradley? It's arithmetic. And Bradley, can you see what our common difference is on this particular sequence? Our common difference is 2, which we may or may not need here in a little bit. But like I said before, we don't want to figure out 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way up to 75. We don't want to sit there on our paper and do that. So we need to go back to some standbys. And we're going to use this formula over here of, I'm just going to point to it. S of n equals n divided by 2 times a1 plus an, which is at the bottom of your paper. There I have it at the top of my screen here, but it's at the bottom of your paper. And we know what a sub 1 is in this problem. A sub 1 is going to be negative 180. It's the first term that we're working with. It's not the first term in the sequence. It's the first term that we're going to work with, which is our negative 180. We need to figure out what a sub n is. In this case, in particular, we're looking at is what does a 75 equal? So we can come back over here to the left of our paper, and we can say, well, when x is 75, what are our values there? So we're going to put 75 back into our function. 2 times 75 minus 200. And when we do the math of that, we end up with negative 50. Separate that out. So we get negative 50. Because again, what we're going to do is we're going to go back into our sum formula, which once again is what sigma equals. It's a sum formula. And our sum formula is n divided by 2 times a1 plus an. So we need to know one more piece of information in this problem. And that is going to be, well, what does n equal? What does n equal? And what n equals here is going to be our last value, which is 75, minus our first value, which is 10. But we need to count the 10th value. And if we do 75 minus 10, we're not counting that 10th value. So in order for us to do that, what we need to also do to figure out n is we need to add 1 in there. So we take the top of sigma, which is 75, the bottom of sigma, which is the 10, and then we have to add 1 more to make sure that we're counting that value of 10 in there. So when we finish this, 75 minus 10 is 65 plus 1 is 66. And now that we have all that information, we can figure out our sum. And our sum is going to be 66 divided by 2 times our first value, if I can get there, first value of negative 180 plus negative 50, and we can type it in. So divided by 2 times negative 180 plus negative 50 gives us our value of negative 7,590. Equals negative 7,590. But I do want to show you one more thing on this, and that is some calculators have a button. I don't know where it is on the Inspire, so if some of you have an Inspire and you can find it, I have looked some now and I haven't been able to find it. But if you do have the traditional TI-84 calculator, what we have to do is we have to type in alpha window. So here's alpha window. And if the board's not disoriented, it will work, but alpha window. And the function that we're looking to use on here is the second function, summation, number 2. And that will allow us to type in this function, which in our case said x goes from 10, arrow up, to 75, and then our function is 2x minus 200 in that parentheses. 2x minus 200. And when we press enter, we should get the same value that we got, which is negative 7,590. So probably some of you are thinking, well, why should I bother learning any of this? Well, I'm not testing you on how to use a calculator. If I want to test you on that, then we'll have a test on that, but that's not what I'm looking for. It's, do you understand the math behind it? And I don't want to not show you how to do something on the calculator. I want you to be able to check your work and go back and find your mistake if you made a mistake. And frankly, the questions on the test are pretty much more specific than just what's the answer. But I do want to show you how to do that. So now that we've seen a couple, hopefully that's going to help us here when we try this one. And it's going to be the same process. We need to go through, find a couple terms. Once we find a couple terms, then we can identify what kind of sequence or series is it. And then finally we can find the sum. It's not quite as daunting because we're going from k is 12 to 32. But when we start this here, we are going to start with k equals 12. So you can get a little bit of a head start on me while I orient this board. K equals 12. So that means that we're going to have 25 minus 2 times 12, which is 1. And when k is 13, we have 25 minus 2 times 13, which is negative 1. And when k is 14, we get 25 minus 2 times 14, which is negative 3. And when k is 15, we get 25 minus 2 times 15, which equals negative 5. And usually after 3 or 4, a couple things happen. One, we see a pattern, which enables us to identify, is this going to be an arithmetic or a geometric series? And hopefully you're thinking arithmetic, and especially with my formulas there in the upper right hand corner, which go with arithmetic. What's our common difference in this particular problem? And it is. Negative 1 minus 1 is negative 2. Negative 3 minus a negative 1 is negative 3. Negative 5 minus a negative 3. So we do need one more value here. We need to figure out, well, what is our value when k equals 32? So we're going to put 32 back into our function, and we end up with 25 minus 2 times 32. And 25 minus 2 times 32 is negative 39. we've got our formulas that we need, and now eventually we need to fill in our sum formula, because that's what sigma stands for. Sum, and it's n divided by 2 times a1 plus an. So let's look at the values that we have here to fill in to our formula. Our first value, even though it's not the first one in the sequence, it's the first value that we're looking at. It's from the 12th term to the 32nd term. Our first term is 1. Our a sub n, which is a sub 32, we just calculated is negative 39. So the only question left here is, what's our value of n? Well, when we look at it here, we're going to take the top number, which is 32, minus the bottom number on our sigma, which is 12. But to count that 12th value, we need to add 1 in. So when we look at this, we're going to deal with 21 for our n. And now we have all the values that we need to fill in our formula, which is going to be 21 divided by 2. And our a1 is 1, and our a sub 32 is negative 39. And we can type that into the calculator. We have 21 divided by 2 times 1 plus negative 39. And we get negative 399. If you were so inclined. Again, alpha window number 2 will let you check your answer with that. But as we flip over to the other side of our notes here, now that we're at least familiar with how do these work, we want to figure out how can we write something in sigma notation. And first of all, we're given 3, 6, 9 plus dot 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 all the way up to 30. How, or not how, but what kind of series, because they're added together, what kind of series is this? Well, it happens to be an arithmetic. It's arithmetic. If you look really close, 6 minus 3 is 3, 9 minus 6 is 3, with a common difference of 3. So common difference is 3. And our first term here is also 3. I wish that I wouldn't have done that. But what we have to do when we want to write something in sigma notation is we have to use our nth term formula, whether it's arithmetic or whether it's geometric. So when we look at this problem here, a sub n equals, off to the side there, off to the upper right corner is our formula, 3 plus n minus 1 times our common difference, which is 3. And we want to simplify that formula. So when we simplify, that's going to require us to use distributive property, distributing that 3. So we end up with 3 plus 3n minus 3 when we distribute. And when we combine like terms, we ultimately end up with 3n. That's the value of our function there. So over here, again, remember, sigma is kind of like a sideways m. Do the best you can. And our function value is going to be 3n. We just found it by using the nth term formula. We're starting with the first term in the sequence. 3 is our first term. The question is, how far are we going? So what we have up here in our problem is that 30, that's a sub n. And if I would have written my formula a little bit better, a sub n equals 30 is what we get in that first bulleted part of this problem. Question? So if we fill in a sub n is a sub n equals 3n. A sub n equals 3n, what we just found. A sub n, we just labeled in the problem is 30, and I can't seem to write this correctly. Because what we want to know is, how far are we going to go? Well, when we divide both sides by 3, 30 is our 10th term in our sequence. I'm going to put 10 up there. Let's try one more here to see if we can get this, see if I can explain it a little bit better. Very similar problem. Again, I need a little bit better example, but it will serve its point here. First of all, as we take a look at this, is this an arithmetic sequence? 2 to 4, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. It is arithmetic. So eventually we want to use sigma, and our first step is to find the equation for the nth term. Well, we know that a sub 1 is 2. Our common difference also happens to be 2. And our formula is a sub n equals a sub 1 plus n minus 1 times d. You need to fill in that formula, but we don't know what n is. So we're going to get 2 plus n minus 1 times 2. And we need to distribute. We're going to distribute the 2. So we have 2 plus 2n minus 2. And just like that last problem, we end up with a sub n equals 2n, because our 2 and our negative 2 canceled out to be 0. So once we have that part, we want to write our summation symbol. And our function value is going to be 2n beside that sigma symbol. We're starting with the first value. And the difference on this problem is it says use sigma notation to represent this for 45 terms. Here's the 45. We didn't have to figure it out this time. So finally here, we need to evaluate the sum. Well, because we started with 1, our n is 45. And so now we're going to use our summation formula, which is n divided by 2 times a1 plus an. So we do need one more piece of information. We need to know, what is a of 45? But the good news is that a of n, which is a of 45, is going to be calculated by taking what's 2 times 45. And 2 times 45 is 90. And we can fill this in. N, not N, 45 divided by 2 times our first value, which is 2, plus our last value that we're counting is 90. And without using the calculator here, hopefully somebody's checking me, we end up with 2070. Problem number 7. Use sigma notation to represent -3 plus 6 plus -12 plus 24 plus -48 all the way up until the 21st term, a sub 21, the 21st term. Then evaluate the sum. So it says find the equation for the nth term. Well, first of all, I kind of give it away by having our little formula up there in that box. But what needs to happen here is we need to look at this and we need to identify the fact that this is a geometric series. And with a geometric series, in this case, as we take a look at this, we see that our common ratio is -2. We took 6 divided by -3 is -2. -12 divided by 6 is -2. 24 divided by -12 is -2, and so forth. And what we really also need to know to do this first part of the problem is we need to know, well, what's the first term? And luckily, that's pretty straightforward. It's the first one in our list here, which is -3. We've got our formula over here. It says find the equation for the nth term, so a sub n equals our first value, which is -3, times our common ratio to the n minus 1. So now that we have that, we're going to take the nth term formula and we're going to put it into our sigma notation. And remember that it's kind of a sideways m is how I think of it when I'm writing it, but our value that we just came up with for a to the n, a sub n, is what's going to go in that position of our sigma. We are starting with our first value. And we're going to go all the way to our 21st value. So the n equal 1, where we're starting, what's our last value that we're looking at? We're looking at the 21st value. And now to finish this problem, what we want to do is we want to figure out the sum of that. So the formula that I don't have written down on your paper is the formula for sum. And that is a sub 1 minus a sub 1 times r to the n divided by r. How about 1 minus r? So now that we have a refresher of that, we need one more value up here in our list. We've got our common ratio, we've got the first term, and we need to know n. But we're evaluating it for the first 21 terms. So when we fill this in, hopefully you have enough space to fill it in on your paper. Our a sub 1 is -3 minus -3 times -2 to the 21st divided by 1 minus -2. So I'm going to have to write over here to the left, but we can type this into our calculator now. And if you have a fraction button, I highly recommend that you use it. And it is -3 minus -3 times -2, common ratio, to the 21st, divided by 1 minus -2. And that gives us our value there. If I can get it on here. That gives us our value of 1,097,153 negative. Now, one other comment here is some of our calculators can type this in and check our work. And when we do, we have to be really careful with typing it in. It's alpha window and number 2. And when we type this in, it's going to be x equals 1, arrow up to put in our 21, and then our value over here, everything from our a to the nth term needs to be inside of those given parentheses. So I'm going to put another parentheses in right now, and it's going to be negative 3 times negative 2 to the n minus 1. So I'm going to use x minus 1. But notice how everything is inside that parentheses to calculate out versus sigma. And hopefully here, I can't remember if I worked it out ahead of time or not. When I press enter, we should have the same value. And whew, luckily we do. Be very careful if you type that into your calculator to check your work with sigma. But lastly, just using sigma, and again, the thing about this is we need to be able to identify whether something is arithmetic or geometric. And when we look here, our first term is 1. But when we look at the rest here, we need to decide if this is arithmetic or geometric. And if we do 5 minus 1, we get 4. But 25 minus 5 gives us 20, and those numbers aren't the same. Which means that this is not arithmetic, as I erase those. But if we try 5 divided by 1, and let me write it a little bit better, we try 5 divided by 1, we get 5. And 25 divided by 5, we get 5. And 125 divided by 5, how about divided by 25, we still get 5. Which means that we're going to be working with a geometric sequence, and it also means then that our common ratio is 5. We now, before we can write it in sigma terms here, we need to come up with the nth term of our function. And remember that a sub n equals a sub 1 times r to the n minus 1. And we've got our values here, with the exception of 1, already written down. We see that a sub 1 equals 1 and r equals 5. So the only other value that we need is, what does n equal? And I'm going to write it off to the side here. N equals 300. We want to use sigma notation to represent this geometric series. And the last value that we're looking at is a sub 300. So we want to look at the 300 terms added together. So now that we've got that value, we can go ahead and write down our sigma notation. We're starting at the first term. We're going to go and look at 300 of those terms. And then when I fill in a sub 1, that's going to be 1 times our common ratio, which is 5 to the n minus 1. Now lastly here, I kind of did it in two steps in one, because I did the nth term within the sigma notation, but because it's 1 times this value, we don't really need to write the 1. But to get the value here beside the sigma Greek letter, A sub 1 was 1, our common ratio was 5, and then n minus 1, because we have to have the nth term. We have to find the equation for the nth term, and then put it into sigma notation.